Welcome to SRA 221. In this lecture, we will be discussing public keys and cryptography usage. Symmetric key algorithms are algorithms for cryptography that use the same cryptographic keys for both encryption of plain text and decryption of ciphertext. The keys may be identical, or there may be a simple transformation to go between the two keys. The keys, in practice, represent a shared secret between two or more parties that can be used to maintain a private information link. This requirement that both parties have access to the secret key is one of the main drawbacks of symmetric key encryption in comparison to public key encryption. In regards to key management, there are two main problems. Key distribution is the first one, requiring the keys to be divided and being sent through different communication channels. Additionally, the sender and receiver need to agree on the secret key in order for the encryption-decryption mechanism to work. In cryptography, Kirchhoff's principle, also called Kirchhoff's disorita, Kirchhoff's assumption, axiom, or law, was stated by August Kirchhoff in the 19th century. A cryptosystem should be secure even if everything about the system, except the key, is public knowledge. Stated simply, the security of a cryptosystem should depend solely on the secrecy of the key and the private randomizer. A method of secretly coding and transmitting information should be secure even if everyone knows how it works. Of course, despite the attacker's familiarity with the system in question, the attacker lacks knowledge as to which of all possible instances is being presently observed. So what is an insecure channel? An insecure channel is wireless, Ethernet, and the internet itself, whereas a secure channel is a physical exchange, phone call, or other dedicated channels the two parties may have. Other problems that are faced are key management issues. The first one is that the key space cannot be too small. We have seen with DES that what happens if the key space is too small in modern computer systems, the encryption can actually be broken in a relatively small amount of time. In addition, there is a problem known as weak keys. Some of the keys in the key space that you have based on the alphabet that you use to define the keys can encrypt very poorly or not encrypt at all. Here is an example of a key space. The key space is basically the number of bits or bytes in the key. A 2-bit key has 4 values. Of course, a key length of n has a key space of 2 to the nth power. So if the key space is 128 bits, there are 2 to the 128th power possible combinations.